Okay, thanks for coming back. We're going to look at numbers 83 and 84 right now, at least on this part. 83 is square root of 18x minus the square root of 2x. It's not square root of 16x. It's a good reminder maybe that the square root of 9 minus the square root of 4 is not the square root of 5. It's 1. So be careful, not equal to the square root of 5. The square root of 5 is not equal to 1. Similarly, if you have the square root of 3, or the cube root of 2 minus the square root of 2, you can't do anything with those. So for this to work, for you to subtract radical expressions, the part underneath has to be the same, but also the index has to be the same. The little power in that little groove notch of your square root thing. So, let's see here. So let's try this one out. So as is, we cannot simplify this. These x's can't do anything with them, because if they're x squared, x cubed, some greater power than 1, we could pull them out, but they're not. This 2 is not looking good because there's nothing square rootable that goes into that. The only hope we have is 18. Unfortunately, there is a square rootable number that goes into 18. So think about your numbers that are square rootable. 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. Of those, these 3 are all less than 18. That doesn't go into 18. 9 does. 9 goes into 18 2 times. And the x has to stay underneath as well. So I call these the leftover. They don't get to escape. But the 9 will. The square root of 9 can now come out. The square root of 9 is 3. So we now have 3 times the square root of 2x minus the square root of 2x. This is not 3. I think of this as like 3x minus x. It's not 3, but it's, or you can think of these as like apples. If you have, let's see if I can draw an apple. If you have 3 apples minus 1 apple, that's going to be 2 apples. Good. So it's going to be 2 times the square root of 2x is our answer. And let's box our answer, or something like that. There we go. Check. 2 times the square root of 2x. Let's do one more. Let's do 84. Okay, 84. The 4th root of x to the 5th. So we have to ask ourselves, what in here is 4th rootable? It may be worth showing you a quick example to the side here. I think one of my classes we did this. This is my favorite example of all time. Cube root of 27, x to the 5th, y to the 6th, z to the 7th. It may not have been exactly this one. So let's break this into what is cube rootable and what is not cube rootable. Still getting the hang of this stylus. Oh, not 27. Let's change that. That's too easy. Make that 54. Okay, so what of 54 is cube rootable? Let's make a list of our cube rootable things. 2 cubed is 8, 3 cubed is 27, 4 cubed is 64. Those are the cube rootables, the first 3 at least, not including 1. 1 never helps us. But which of these are less than 54? These 2 guys. Those are our only hope. Does either of them, well, let's check 27 first. Does it go into 54? It does. Twice. So 27 is cube rootable. X to the 5th, is it fully cube rootable? No, but 3 of those x's can be pulled out. The leftovers get thrown in this pile. Y to the 6th, is it fully cube rootable? Yes. No leftovers. Z to the 7th, is it fully cube rootable? No. I'm going to need an eraser again here. So how much of z to the 7th is cube root of z to the 6th? There's 1 left over for here. All this gets cube rooted and becomes 3x y squared z squared. As those come out of the cube root, you're dividing the exponents by 3. The leftovers, poor leftovers, stay here. Don't forget that index of 3, and you're done. You might notice, I should make that a little darker dot. That's just a dot, just to make sure I don't confuse that exponent here with this exponent. So, okay. Hope that helped. I'm going to click over to another video to do the last one here. Thanks.
Made with Doodlecast Pro.